Alright guys, this video is for Honors Algebra 2. It is 6-1, Operations on Functions. It's a pretty easy lesson overall. Basically what you have to do, basically what it is going to be adding and subtracting functions, the function notation, using function notation. It's going to be operations that we've all done before. It's going to be, whoops, let me back up here. There we go. It's going to be addition, subtraction, multiplication, and division. So it's going to be all four of these. If you look over here at the example, it says like let f of x equal 2x and g of x equals negative x plus 5. The notation you're going to be given is like this, and then you just convert it to f of x plus g of x, and then you literally just add them up. You combine like terms, so 2x plus negative x plus 5, so 2x minus x gives you x. Down here you subtract them, so you distribute the negative sign through, so 3x minus 5. Here you multiply them. The only thing with division is you have to tell you what the denominator cannot be. So like if it's f of x over g of x cannot equal 0. So you have to figure out what the denominator cannot be, because if you plug in numbers, since we are adding these functions together, the denominator can't be 0. Okay, so a couple of examples here. So for this one, you have f of x being x squared minus 4. You have g of x being 2x plus 1. Identify or find each function. Indicate any restrictions on domain or range. So basically what you do is you take, just to show you, you do f of x plus g of x. So remember, it's always going to look like this, but you got to think about it like this. You substitute x squared plus 4 in, plus, 2x plus 1, and then you go through and do your like terms. So x squared plus 2x plus 5, and that's it. And then on the second function, f of x minus g of x. So same deal, f of x is x squared minus 4, minus, make sure you put g of x in parentheses, because you have to distribute that negative sign through, so it'll be x squared minus 2x minus 5 for that guy. So it's very simple operation, stuff you already know how to do. It's just basically different notation of setting it up, and setting it up in function notation, not so much as just here's the problem, but you've done everything here that we've done before. So a couple different ones now. F of x equals x squared plus 7x plus 12. G of x equals 3x minus 4. So you have f times g of x this time, so we're going to multiply these. So f of x, you don't have to show this step here, but just for today I'm going to, times g of x, so you have x squared plus 7x plus 12 times 3x minus 4, and you're just basically going to distribute that through. So 3x times x squared plus 7x plus 12 minus 4 times x squared plus 7x plus 12, then run through your distributes. So 3x cubed plus 21 x squared plus 36x minus 28x minus 48. Go through and do your like terms, so you get 3x cubed plus 17x squared plus 8x minus 48. And that's that. As far as division goes, you don't have to, you guys are probably thinking it's harder than what it actually is. You really don't need to do too much for f over g, so basically you just set it up, do f of x, and then put it over g of x, which is 3x minus 4. The only thing you have to do, you don't have to like actually do that division. So if you're thinking you have to synthetic divide that, you don't. You don't need to simplify divisions for me. What you need to do though is figure out what denominator cannot be. So it cannot equal 0. And so basically you just solve the denominator like this. So you add 4 over and divide by 3. So x cannot be 4/3. So you just basically look at it, you solve the denominator, you tell me what number you cannot plug into that function. Since it is division, you would have divide by 0, and you can't do that. Okay, so that's half of this lesson. The other half is called composition of functions. Make sure of all the things on the slide, if the box can be a little confusing to you, make sure you understand this notation right here. So that's not, this is like a little degree sign. You don't say fog of x, you say f of g of x, that's the way it's said. And basically what you're doing is you're figuring out you're figuring out a subset of g. Let me restart. You're figuring out what g of x is, and then you're evaluating that with f. So you're basically doing two functions at one time, plugging into this function first, into your g first, and then plugging that results into f. So if you follow along on the paper, on this map here, you have some number that's in the domain of g, so you can plug it into g. You find that number, which is in the range of g, right? Numbers you put in are your domain, numbers you get out of your ranges. And then you put that number in the domain of f. So you take that range out of g, put it in the domain of f, and then the final answer is in the range of f, or the final answer in f. So basically, it sounds a lot more complicated than what it is, so I'm just going to stop talking in circles and move on. Basically, the way you work composition of function problems is you work them inside out. So you have f of g of negative 2 here. So the first one you do is g of negative 2. And you do that just as you would think you would. You'd plug negative 2 into your g function. In this case, that's 4x. So 4 times negative 2 gives you negative 8. Then you find f of negative 8. See how this replaces all of this here. So f of negative 8 would be 2 times negative 8 minus 5, which gives you negative 16 minus 5, which gives you negative 21. And then that's it. That's your answer for that one. Then for g of f of 7, you follow whichever way the function is asking. So last time I went g first, this time we're going to go f first. So f of 7 equals 2 times 7 minus 5, which that gives you 9. And then we're going to go g of 9, which is 4 times 9. So you get 36. Okay, and then f of 6, so you plug 6 into f. So 6, 2 times 6 minus 5 gives you 7, and then you take that result and you go back into f. So that can happen on these. So 2 times 7 minus 5, which will give you 9. You can do these with just numbers. You can also do them with other functions. So here we're going to find f of g of x and g of f of x of these two functions. So we're going both ways with this slide here. So we're going to do f of g of x first. I always, kind of run it like a substitution. So g of x, whatever it is, I'm going to plug in first. So then f of 4x, we'll plug that in, and then f function is 2x minus 5. So whatever's in here goes into the x's here. So you have 2 times 4x, which gives you 8x minus 5. And since there's x's involved, you have to do like terms and stuff like that. That's all you can really do with that one. And the other one says do g of f of x, so g, let's change color there. So g of f of x. So then you do g, f in this case is 2x minus 5. You plug that 2x minus 5 into the x in your g function, so that'd be 4 times. So 4 times 2x minus 5, and then you just distribute. So 8x minus 20. Okay, and then the last example, same deal, same question, find f of g of x and g of f of x. So we're going to do f of g of x here. So g of x in this case is x minus 6. So you replace the x, so that means that instead of x being squared, x minus 6 is what gets squared. And then we're going to add 2 to that. So make sure, like I said, one of the most important things you guys will need to learn is how to square a binomial. Here's another example of it. So you FOIL this out. So x minus 6 times x minus 6 gives you x squared minus 12x plus 36 plus 2, which gives you x squared minus 12x plus 38. And that's your final answer there. The other one, we're going to do g of f of x, which is a lot easier. So g of x squared plus 2. So you plug that into the g, x and g, so it'd be x squared plus 2 minus 6. Combine some like terms, you get x squared minus 4. Since you're simplifying these, you don't need to factor that or nothing. Guys, that'd be the lesson. Hope it went well. You got homework assignment for page 389, 11 through 15, 30 through 35, 45 through 48.